Hi everyone, today we're going to be solving AQA GCSE Chemistry Higher Tier Paper 2. In this particular video, we're going to be solving from SPECIMEN 2018 from question number 6 to question number 10. This is a part 2 of the question paper. And guys, don't worry, all of this question paper are going to be placed in a playlist. Question number 6. Ethene is used to produce polyethylene. Draw the bonds to complete the displayed formula of the ethene and polyethylene in the equation. So an ethene molecule is an alkene molecule, must have a carbon-carbon double bond. The remainder of the bond will be with hydrogens. In a polyethylene, the ethene has completed polymerization. The carbon-carbon bond has turned into a single bond in two hands at two ends, and the remainder bond will be between the carbon and hydrogen. Polyesters are made by different method of polymerization. The equation for the reaction to produce a polyester can be represented as, we can see a dialcohol reacting with dicarboxylic acid to produce an ester, and a water is released. Compare the polymerization reaction to produce polyethylene with the polymerization reaction to produce a polyester. So our points will include polyethylene produced by addition polymerization, whereas polymerization for polyester is a condensation polymerization, and polyethylene produced from one monomer, whereas polyester is produced from two different monomers, which in this case is the dialcohol and the dicarboxylic acid. Polyethylene produced from ethene, alright, whereas polyester is produced from a dicarboxylic acid and a dialcohol. Polyethylene is the only product formed, whereas polyester also produces a small molecule of water. Polyethylene repeating unit is a hydrocarbon, whereas polyester has an ester linkage, as you can see in this diagram. The student investigated food dyes using paper chromatography. Put a spot of food coloring X on the start line. Put spots of 4 separate A, B, C, D on the start line. Place the bottom of the paper in water. Leave it for several minutes. Figure 5 shows the apparatus the student used. Start line drawn in ink. Okay, so obviously this is a mistake. It must be drawn with a pencil. Write down 2 mistakes the student made in setting up the experiment and explain what problems one of the mistake could cause. So the other problem is, you see the ink line is below water. It must be above. It must be drawn with pencil and it must be above water. So these are the two problems. So the answer will be water level is above the start line and the start line is drawn in ink. Food colors would dissolve into the water and the start line, which is drawn in ink, would run on the paper as well. Another student set up the apparatus correctly. Figure 6 shows the student's result. The result for die D is not shown. Calculate the RF value of die A. Give your result to two significant figures. To calculate the RF value of die A, two measurements need to be done. One, we need to measure the middle of the spot from the start line to the middle of the spot. And second, we need to measure from the start line to the solvent front. Then we need to calculate the RF value by using the formula solvent distance traveled by the solute divided by the distance traveled by the solvent. Die D has an RF value of 0.68. Calculate the distance that the die D moved on the chromatography paper. We know that RF is equals to distance traveled by die D divided by distance traveled by the solvent front, which is 8.2. The RF value is already provided, which is 0.80. 0.8 times 8.2, 6.6. Explain how the different dyes in X are separated by chromatography paper. The solvent moves through the paper. Different dyes have different solubilities in the solvent, and as a result, different attraction for the paper. And because they have different attraction for the paper and they have different attraction for the solvent, so they are carried different distances on the paper. Flame emission spectroscopy can be used to analyze the metal ions in solution. Figure 7 gives flame emission spectra of 5 metal ions and a mixture of 2 metal ions. Use the spectra to identify the 2 metal ions in the mixture. So we can see, first of all, for the calcium ions, these spectra, they easily match with the mixture of the 2 metals. And the other one that we get a clear band is, we can see the sodium ions emission spectra directly matches with this one, the mixture of 2 metal ions. So we can conclude that there is sodium and calcium ions. Sodium ions and there is calcium ions. Explain why a flame test could not be used to identify the 2 metal ions in the mixture. The reason why we couldn't use a flame test is because there is a mixture of 2 different colors. And the calcium one, the calcium has an orange red color in the flame test, and sodium has a yellow color in the flame test. And when we are gonna have both of the metal ions in the solution, the colors are going to mix together. So as a result, one color will mask the color of the other one and give us a combination result, which will be difficult for human eyes to detect which 2 metal ions are present. Two students tested green compound X. The student added water to the compound. The compound X did not dissolve. The student then added a solution of ethanoic acid to the compound. A gas was produced which turned lime water milk. So we can understand from the second test that this is a carbonate. And since it says that it's a green compound which is a carbonate, it must be copper carbonate. Student A concluded that compound X was sodium carbonate. Student B concluded that compound X was copper chloride. Which student, if any, was correct? Well, we can see both of the students are wrong in this case. The student A was incorrect because sodium compounds are white, they are not green. Sodium carbonate is soluble in water, so can't contain sodium ions at all. The student B is incorrect because adding an acid to carbonate produces carbon dioxide. So the solid must contain a carbonate, not a chloride ion. Fertilizers are used to improve the agricultural productivity. Ammonium nitrate is used in fertilizers, named to compound used to manufacture ammonium nitrate. So ammonium nitrate can be manufactured using ammonia and nitric acid. A fertilizer contains the following information on the label. NPK value 14:11:11. Explain why the information is useful to farmers. The formulation shows that what the fertilizer contains. So the farmer can choose fertilizer with the required properties. Figure 8 shows the worldwide ammonia production and world population from 1950s to 2010. So worldwide ammonia production and world population both goes hand in hand. We can see both are increasing from 1950s to 2010. Figure 8 shows your knowledge to explain the relationship between ammonia production and world population. We can see from the graph that as the world population increases, the ammonia production increases. Ammonia is actually used for fertilizers. So increasing need from increasing amount of population for fertilizer, since more food is required for an increased population. Marble chips are mainly calcium carbonate. A student investigated the rate of reaction between marble chips and hydrochloric acid. Figure 9 shows the apparatus the student used. Hydrochloric acid, 20 grams of marble chips, measuring cylinder, bubbles of carbon dioxide collected over water. Complete and balance the equation for the reaction between marble chips and hydrochloric acid. So marble chips is calcium carbonate, so we're going to write CaCO3, and it reacts with hydrochloric acid, which is HCl. Now, once the reaction completes, it produces carbon dioxide and also produces H2O. So since there are two chlorines on the right hand side, so there must be two in the left hand side as well, 2 HCl. So CaCl2, CO2 and H2. The equation is balanced. Table 4 shows the student's result. You can see the result, time in seconds, and volume of gas in dm³ produced. Plot these results on the grid. Draw a line of best fit. Okay, when we have a situation like this where we have to label the volume of gas and also the time in second, we are going to look into the information that we have. We have time up to 270 seconds. So 1, 2, 3, 4, 5, 6, 7. Within 7, we have to complete 270 seconds. Now the ruling is we have to at least use 2/3 of this particular graph paper. So if we take each box to be 50, then 100, 150, 200, 250, 300, and we're going to have 350 in the end, which pretty much can cover up more than 60% of the graph paper. In terms of volume in dm³, the maximum volume in dm³ we can see is 0.08. So 0.1 will be the maximum. Okay, so we can see 1, 2, 3, 4, 5. We have 5 places to put in the values. So we can start like 0.02, 0.04, 0.06, 0.08. And then we can go like 0.10. In this case also, we will ensure that we are using more than 2/3 of the graph paper, or like around 60%. So this particular point being 0, 0. Sketch a line on the grid in figure 10 to show the results you would expect if the experiment was repeated using 20 grams of smaller marble chips. Because we're going to use the smaller marble chips, we're going to have a more steeper line and the reaction will finish faster. But it will reach up until the same level because you're using the same amount of reactant. Explain in terms of particles how and why the rate of reaction changes during the reaction of calcium carbonate with hydrochloric acid. So during the reaction of calcium carbonate with hydrochloric acid, the acid particles are used up, so concentration decreases. As a result, less frequent collision occurs per second. So the rate of reaction slows down. Another student investigated the rate of reaction by measuring the change in mass. Figure 11 shows the graph plotted for these students' results. to 300, mass of flask and its content in grams. It decreases gradually, So it is decreasing mostly because the CO2 is escaping from the glass, from the reaction vessel. Figure 11 shows to calculate the mean rate of the reaction up to the time the reaction is complete. Give your answer. 3 significant figures. Okay. So first of all, what we have to do is, what is the mass lost in total? We'll have to find that out. All right. And then we're going to find out what amount of time taken for the reaction to complete. Then we're going to divide the mass lost by the time that it takes. The answer will be in obviously decimal form. And then from there, we're going to give the answer in 3 significant figure. Any, zeros just right after 0 point, will be invalid. They are not considered as a significant figure. So wherever the numbering starts, it will start from there. So from there, we will count 3 significant figures, 3 letters. Use figure 11 to determine the rate of reaction at 150 seconds. So you're working, give your answer to standard form. So at 150 seconds, we'll have to draw a tangent. So we're going to draw a tangent at 150 seconds. Try to get it as correct as possible. Otherwise, the result will be a problem. So rate. To find out the rate, we'll have to use the formula reservoir. So it will be 7.36 into 10 to the power of minus 10 to the power of minus 3. So guys, to find out this particular answer, what we did is we drew a tangent that exactly touched 100 and we extended the line until it touches both of the axes. Then all we did was we used the formula gradient is equals to rise over run. And you do this every time you'll get the correct answer, guys. In industry, ethanol is produced by the reaction of ethene and steam at 300 degrees Celsius and 60 atmosphere pressure using a catalyst. The equation for the reaction is ethene plus steam produces ethanol. The flow diagram shows the process. Ethene and steam is injected into the reactor. It goes to the separator where the ethanol and water, our mixture of ethanol and water is extracted, and unreacted ethene is put back into the system. Why does the mixture from the separator contains ethanol and water? Both water vapor and ethanol will condense in the separator. However, ethene has a much higher boiling point, so it doesn't condense. The forward reaction is exothermic, using Le Chatelier's principle to predict the effect of increasing temperature on the amount of ethanol produced at equilibrium. Give a reason for your prediction. Since the forward reaction is exothermic, always remember in a reversible process, if the forward reaction is exothermic, then the backward reaction will be endothermic. That means if we increase temperature, we will favor the backward reaction. So the amount of product will decrease at equilibrium because the equilibrium will shift to the left, producing more reactant because the reverse reaction is endothermic. Explain how increasing the pressure of the reactants will affect the amount of ethanol produced at equilibrium. If we look back into the equation, we can see 2 moles of gases are converted into 1 mole of gas. So if we increase pressure, we will favor more product. More methanol will be produced because the system moves to fewer molecules. So guys, that's the end of the question paper. Thank you for watching the video. And guys, question papers like this will be uploaded consistently. If you subscribe to the channel, then you will always get notified of the question papers that are getting uploaded. And if you have a friend, notify them about the channel as well. And guys, subscribe and help the channel to grow. Thank you so much.